Module 3.5, pooling it together, is very similar. It's talking about the same story that we talked about yesterday or earlier this week when we did 3.4. So Allie and Dane, they work at a water park and they have to drain the water out of their rides at the end of each month. And each of them uses the pump to remove water from the pool at the bottom of their ride. Here's a graph of Allie's pool and Dane's pool over time. And here's what happened. So yesterday, or when we did 3.4, we looked at the graphs and we wrote an equation for Allie and we wrote an equation for Dane. So if you remember, Allie's equation, I think, is a of x, and I feel like I did this one in orange. We graphed it. So Allie's equation is a of x. And she starts with how much water? So Allie starts with 28,000 gallons, so that's her y-intercept. And then the tricky part about this lesson in 3.4 was finding the slope, finding how much water was pumped out each minute. And we talked about doing rise over run. So if I was going to do a slope triangle for Allie's graph, I would say, hey, it took Allie drained 28,000 gallons. So her rise was 28,000 gallons. And how long did it take her to drain those 28,000 gallons? It took her a total of 20 minutes. So her run was 20 minutes. So her slope is those 28,000 gallons divided by the 20 minutes is going to give us her slope. So when I put that in my calculator, 28,000 divided by 20, I get 1,400. So that is her slope. And the water was decreasing, so actually the rise was negative 28. So Allie's equation is a of x equals 28,000 minus 1,400 gallons per minute, 1,400x, right? So that's what we did when we did module 3.4. And then we had to do the same thing for Dane. So Dane, I feel like I highlighted in blue when we did this lesson. He's d of x. So d of x starts with how much water? He starts with 24,000 gallons. So that's my y-intercept. And then we need to do the same thing to find his slope. So the rise for Dane was he drained, so that's negative 24,000 gallons. And then how long did it take him to drain those 24,000 gallons? It took him 24 minutes. So that was my run. So my slope is going to be those two divided. So if I take negative 24,000 and I divide it by 24, I get 1,000 gallons per minute. So Dane's equation is 24,000 minus 1,000 gallons per minute. Right? So that's the work that we did when we did module 3.4. So today we're saying, hey, Allie and Dane are friends and they want to hang out. And so what they decided to do is to work together, and they're going to use both Allie's pump and Dane's pump to pump the water out of their pools at the same time. So, but they are also, so they're going to take both pumps and they're going to put them in Allie's pool, and then they're going to take both pumps and put them in Dane's pool. So together, if they're using both pumps, one of their pumps pumps at 1,400 gallons per minute, and the other pump pumps at 1,000 gallons per minute, right? So if they're using them together, how many gallons are they going to be able to pump out each minute? Hopefully you said, oh, together, that means add. So that's really, if they work at the same time, they're going to be able to pump 2,400 gallons each minute. That's going to pump faster, which means my line's going to be steeper. You are totally correct. But they have to drain both pools. So how much water is that going to cost, or how much water is that going to be total that they have to drain? They're going to have to drain Allie's 28,000 gallons and Dane's 24,000 gallons. So G of X is what happens when it's the new story of all the gallons of water that need to be pumped out of both pools using both pumps. So question number 1 says, what does G of X represent? It represents Allie and Dane working together to drain more water faster. Question number 2 says, write an equation for G of X, which we sort of just did when we were talking about that. So if I have to combine, if I'm working together, they have to drain all the water from both pools. You're going to add the 28,000 and the 24,000. So when I do that, I get a total of, I think, 52,000 gallons total. So they've got, if they work together, they have more water to drain. Yes, 52,000 gallons. But they also are draining more water. They're draining it faster because they're using both pumps, which we already added those together. And that gives us 2,400 gallons per minute. So this is your equation for the function G of X. So if they worked together, they have a new equation. That's the teamwork equation, right? And this is what the equation is. They'll have more water to start with, but they'll pump at a faster rate. So question 3 says, now that you have this new equation that you wrote, can you graph it on a new axis? So we have given you this new set of axes. We need to start. Here's our equation. G of X has a y-intercept of 52,000. And then, and then it drains 2,400 gallons per minute. So you're going to start with your y-intercept here on the y-axis. So that is about here. And then you're going to go down 2,400, down 2,400 every time you go over 1. So about here, and you're going to keep using that slope. And you're going to really figure out how long is it going to take them to get to 0 gallons, because that is going to be where you land on the x-axis. So how many times does 2,400 go into 52,000? Maybe if you can do that division, it'll tell you how many minutes it takes when the pool is empty. So you're going to work on creating that graph. And then finally, the last question says, why does it work that you can add the y-intercepts together to find, why does it work that if you took Allie's y-intercept and Dane's y-intercept that you get the new y-intercept of the G of X equation? So that is a question to talk about and then explain for the last question in the module, or in the formative today.